So we're going to work out if the delta H is positive or delta H is negative. If delta H is negative, the reaction is hot. So that's how you know if they're hot or not, the chemicals anyway. And so this delta F is the first of a few delta H subsets. The most important thing to know, because formation sort of explains itself, that the elements, that the compound is being formed, but everything including reactants and products is in the standard state. So if you have a look here, that's normally a solid, normally a gas, and it's 1 mole of the thing. And so these things, halves, actually exist in this mathematical state that we have here to do these calculations, always at 298 Kelvin, 1 by 10 to the 5 pascals. And so we're forming the compound. All right, so if we look at some examples here, first of all, how do we know if it's reactants minus products or products minus reactants? Well, we know from the definition that the elements in their standard states are forming products in their standard states or reactants in their standard states. So the only way you can mathematically get from A to B is going in this red arrow direction here, which means we have to reverse the sign, so it must be products minus reactants. Now, I highly recommend, because you must know the definition anyway, there's no point memorizing this here. I do have the flashcards there for you to memorize the definitions, and you use that to work out what the formula is. I know it takes longer. I do it every time because it means less memorization and it means you don't stuff it up. So here is the example. Now you're going to work out, especially if I just jump to the second example, this is the next video, which is actually delta H of combustion. And so that is something in itself as well. And then the next video over that, I'll be doing delta H of bond energies. So you can see just with this one here, we're going to go back and learn 3 different ways, and there's probably more, but 3 clear different ways of using different types of delta H's to get the delta H of the reaction for that one. And so I might just skip that one since you're looking at that one already, and I'll just go back to this one here. So this one here, we're trying to work out the delta H of the reaction using delta HFs. And so the delta HFs are all given to you here, and you already know it's products minus reactants. So you just basically just add them up. So we've got, we'll just check it off that we've got it right. So we've got calcium carbonate, and this is the reactants. So it should be on the other side. Here we are. This is the reactant side. So minus that. That's the reactant, so we have to minus that final answer. So we just check that that's been done. And then 2 HCl's. The HCl's are 167, and so they're over there, and we've times it by 2, so that should mathematically work out correct, and we should have that bit. Now make sure your setting out is good. Make sure you clearly do each part, reactants, products, and then put it together. It'll save you making mistakes with all the little, these plus or minuses are critical, and it's very easy to stuff that up. So you need to write it out nice and clear. Let's just double check that the products are okay. There's just 1 of each, so there's no timesing, and the leftovers are this one, and this one, and they're all in there, and they're all negative, so we get that value, and that's being transcribed correctly here. So that's the final answer. So please set it out exactly like that, or always actually rewrite your equation on your book, and double check that it is balanced as well, besides doing this bit, and then the third bit. Okay, and just to jump back to here, this one's exactly the same. You can pause if you want. Just side notes, just making sure they're times and making sure you don't stuff up those little units over there. And so this one's slightly harder. So we've worked out the enthalpy per mole, and then it's how much per 11 grams. So you have to change those 11 grams into moles. So that one's not set out fantastically. Oops, so that's number of moles. Equals mass on molar mass, and that's what you've got there. So 1 mole is to 2046 joules, minus 2046, so 0.25 is to x, therefore x equals minus 2046 times 0.25, and don't forget the minus there, which I have there in the PowerPoint. All right, and that should give you -5, 511.5 kilojoules.